Hi everybody and welcome back. This is First Derivative Test Part 2. Okay, and what we're going to focus on today is where the graph is increasing or decreasing. And we're going to use the first derivative to determine those values. Now if you remember from yesterday and the day before, what we did is essentially we found the critical points of a graph. Here, 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 and of course at the end points. Okay, we found all of those critical values, and then we put them on what we called our first derivative number line, and that was the component we added yesterday. So that's what I'm going to do, is I'm going to kind of mark these off on our first derivative number line. Okay, this one here. This was another critical point going all the way down. Another critical point. Okay, here was another one. And finally, the last critical point. And I'll make some adjustments here just to make them a little bit neater. All right, so essentially what we have here, and I'm going to zoom in on this bottom area. Okay, see if we can zoom. We were already zoomed, huh? How about that? Yeah, that's it. We're going to zoom in here, if I can, and focus right here on this graph. Now notice here, I want you to notice something about our graph. In this region, from here to here, the graph is going down, right? Well, when it's going down like that, we say it is decreasing. And from here to here, and then from here down to here, it is also decreasing. So in those three zones, the graph is decreasing. And that's significant, because if we were actually to find the derivative values in those three zones, those derivative values would be negative. So we'd have negative in that zone, negative in that zone, and negative in that zone. Okay? And so these mark on our number line the critical points, wherever they might fall. Okay? Now in the other regions, of course, if it's not decreasing, the graph is probably going to be increasing. So in this zone, we see increasing, and here we see increasing. Okay, so what that means for our first derivative then is that in these areas, the first derivative is going to be positive. Okay, so notice this goes negative, positive, negative, positive, negative. And for most polynomials, that will alternate that way. Not all of them, but for the majority of them. All right, so the key here to remember is this. All right, I'm going to give us a little note here. The key here is to remember when the first derivative is positive, the graph will be increasing. The graph, or I should say this is the function, will be increasing. Okay? Then, when the first derivative is negative, the function will be decreasing. Okay, so we need to know these basic rules. And if you can follow these basic rules, when we set up our number lines, you'll know exactly where things are increasing and decreasing. Okay, so let's take a look now at a problem. Here's a sample problem. And just like yesterday, we're going to do the first derivative test, which implies we take the first derivative. And of course, the first derivative test meant finding critical values. So that's what we're going to do here. We're going to say dy dx is equal to, let's see here, 6x squared minus 12x. And of course, we're finding critical values, so we set that equal to 0. So we factor out a 6x, and we have x minus 2 equals 0. Computer's being a little slow here. So we get x equals 0 and 2 for our critical points. Now that's what we're going to put on our number line. Okay? Here's our number line. That's where it's going to be. All right, so we have 0 and we have 2 on our number line. And of course, there should be an arrow over here as well. Okay, f prime. Remember, label this f prime for first derivative, or you could also label it dy dx or y prime. I would take any of those. All right, now just like yesterday, we're going to determine where we're negative and positive. Okay, so to do that, we test values. For instance, over here we have the value of 3, and we're going to take that 3 and plug it into our derivative. So that would be 18 times 3 minus 2 is 1. 18 times 1 is a positive number. Okay, now let's pick a number between 0 and 2. That would be, yes, 1. Thank you. Okay, so we're going to take a 1 and plug it in here and here. That would be 6 times, oh, that would be negative 1. 6 times negative 1 is a negative number. Okay, now we take a number less than 0, like negative 1. That'd be negative 6 times negative 3, which is a positive value. Okay, so that tells us a few things here. Just as a reminder from yesterday, remember when it's going from positive to negative, you have a max. Okay, when it's going from negative to positive, you have a min. Okay, now here's the real rub today. Today I want to find the intervals where the graph is increasing or decreasing. Okay, so we say for increasing, let me get a better color. The graph is increasing from, well, down here is negative infinity. All right, so it's from negative infinity to 0, the graph is going to be increasing. Notice the bracket here. Okay, that means it can include the 0. Or, that's the or symbol. Now look, it's also increasing from 2 to positive infinity. So we say 2 to positive infinity. Okay? But then also we have to tell where it's decreasing. Okay? It is decreasing from 0 to 2. From 0 to 2, so we just say 0, 2. And that would be the intervals. And these are our answers to this particular question. Where is the graph increasing and where is the graph decreasing? But the first derivative test tells us all of this information. Not only the location of the maximum mins for your critical values, but it also tells you where the graph is increasing or decreasing. All right? Very good. Let's try another. All right, here's our function now. So, of course, the rule is take the derivative. And remember the other day I showed you this little rule for derivatives. If you have the square root of u, its derivative is going to be u prime over 2 times the square root of u. Okay, that's kind of important, and we're going to look at that now. All right, so we say dy dx equals u prime, which is 1, over 2 times the square root of x minus 3. Okay, that's our derivative. By memorizing this, this is going to save you a lot of time and heartache when you go to do these problems. So remember, critical points occur now. We have to think about this. Where? Oh, yeah, that's it. Who can help me out? Well, yes, what's that? Ah, yes. Critical points occur where the derivative is equal to 0 or where the derivative is undefined. Now this guy will never equal 0, this derivative. Really? Yes, that's true. So the only place it will have a critical point then is where it is undefined. And what makes it undefined? Well, that's where this is equal to 0. So we say x minus 3 equals 0 or x equals 3. So this is the only critical point on our graph. So we say, well, let's think about this. We have our number line. We're going to label it. Okay, here's the 3. Well, if we pick a number to this side of 3, to the right of 3, okay, well, like 4. If I plug a 4 in here, I get 1 over 2 times, yeah, that's going to be a positive number. Okay. But if I pick a number less than 3, let's see, oh, Let's say 0. I get 1 over 2 times 0 minus 3. Wait a minute, that's a negative under the radical. That's not good, is it? Well, what that means is, wait a minute. Hey, if I pick any, can I pick any value less than 3? If we have any number less than 3 and we put it in the original function, we get an imaginary number. So the smallest you can go on this guy is 3. So technically, our number line should be stopping right here, and none of this exists, okay, because it's not in the original domain. So our number line actually starts at 3 and works our way up to positive infinity. So what does that mean about where this graph is increasing? Well, it means it's increasing from 3 to positive infinity. Where would it be decreasing then? That's right. It's decreasing never. Okay? So in this case, and a lot of times this happens with radicals, it'll either be only increasing or only decreasing and not both. Okay, so just pay attention to that. All right, one more quick example. Well, sort of. Just to make sure we're good. Take the derivative, set it equal to 0. That's our first step. 36x cubed minus 4x. And we set that equal to 0 because we're finding critical values. All right. So let's see. Let's take out the GCF. That gives me 4x as a GCF, and 9x squared minus 1 equals 0. Okay. So we get x equals 0, and 9x squared minus 1 equals 0 means, let's see here, equals 0. That means 9x squared equals 1, x squared equals 1/9. Therefore, my other critical value, if we take the square root here, will be plus or minus 1 over 3. Okay, plus or minus 1 over 3. So, what that now gives us is our critical values, and we can set up our number line now. Hee-hee! All right, here's our number line. So we can put 0 right here in the middle, positive 1/3. This is very similar to a problem I think we worked yesterday. It might be the same numbers. Okay, so let's see here. Let's get some values on here. Let's pick a number bigger than 1/3. What is it? Come on, help me out, help me out. I heard a lot of ones there in the background, so I'm going to take a 1 and plug it in. So that's 4 times 9 minus 1, so that would be positive. Okay, so if I pick a number in between here, like 1/4, well, that would still be 1, but that would be 9/16 minus 1, so that would be negative. Now I'll take a negative 1/4 and plug in. Well, that would be -1, and that would be negative, so we're positive. Check those numbers on your calculator if you have to, okay? And then I'll take a number like -1 and plug in. That's a negative, and that's a positive, which we know ends up being a negative number, okay? So we can tell all sorts of things here. You should be able to by now. Positive to negative, minimum. I mean, negative to positive, minimum. Positive to negative, maximum. Negative to positive, minimum. So this guy has 2 minimums and 1 maximum. Okay? Really, that's not too bad. Now, where is the graph decreasing? Let's start with the decreasing this time. Okay, remember, it's decreasing when the first derivative is, that's correct, negative. Okay, so it's decreasing from, well, you remember this is negative infinity out here. So negative infinity, comma, -1/3, 0, 1/3. Should be an or symbol in between here. Okay, that's where it's decreasing. And we can also say where it's increasing. Oops, I forgot to label my number line. Don't forget, you could lose points for that. It's offensive. Okay, it's increasing. Remember where your derivative is positive. So that would be from -1/3 to 0. And then or 1/3 to positive infinity. And there you have it, guys. All right, it's been fun. Thank you very much. I've had fun. You've had fun. Hopefully we've all had fun. And I'll see you tomorrow.